No, there's nothing wrong with your TV set. It's just that compared with the razzle-dazzle of the modern world, the past was really pretty colourless. And in spite of what you may think, the food in that picnic was monotonous, limited, and bland. So it's odd that ad men today tend to sell consumables like this, with images of the past like this. It's all made to look like an age of rosy apples, farm-fresh eggs, crusty loaves, simple pleasures. The way things used to be. The real thing. Truth is, of course, our food's far healthier than theirs ever was, whatever the commercial tells you. Why? Well, that's what this program's all about. How, thanks to a couple of clues you're looking at right now, we're able these days to make it all better than the real thing. I suppose if the naughty 90s, the 1890s that is, really were naughty, one of the reasons was this piece of immoral technology. I mean, back then, riding a bike was playing fast and loose, not what nice boys and good girls did. Thanks to the bicycle and the new rubber tires, it was the latest daring thing to do to go out into the country on a picnic before you were married. But a girl still had to stay respectable, which wasn't easy on a bike. Even though some woman in Seneca, New York, called Amelia Bloomer, had invented bloomers to make cycling more respectable, that still left the immoral matter of visible ankle. So the only way to save your reputation from getting the boot was getting a boot, which was a royal pain in the lower leg because it took all day to do up the laces. Until, yippee, around 1913, an engineer called Sundbach came up with the answer, which, speaking of morals as we were, was great news for a multiple bigamist who had 5 simultaneous wives and called all his daughters Mary so as not to blow his cover. He loved zippers on boots because this guy made the machines that made the boots. Meet Isaac Merritt Singer of the sewing machine of the same name, a mechanic turned actor turned social climber who beat his women up, a real sweetheart. But he made a fortune and built factories all over the world because he invented so much down and so much a month. And something else you'll see now. You can't really miss it. Okay, you get the point. Singer's machines are cheap because they're made of interchangeable parts. An idea Thomas Jefferson has brought back earlier from France. Well, he's also had this row with a French scientist called Buffon, who's written a book about, well, let's say, everything since creation. Buffon's book contains a vitriolic attack on America, which he's never been to. According to Buffon, everything in America is retarded because it's so cold, and degenerate American life forms are inferior to the French. Knocking America becomes popular with other French scientists who've never been there either, and who invent 37-pound Louisiana frogs, and everything American having syphilis. But what riles Jefferson most is Buffon's remark about all American animals being smaller than anything French. Things have now really hit the fan. So Jefferson tells somebody in America to mail Buffon a consignment of large American animals with a note saying, "How'd you like them apples?" The Americans make their point. Buffon eats his words. And that's the end of that. Jefferson and Buffon, and everybody else back then before Darwin, were all deeply into something known as the great chain of being. The idea that God, at creation, had designed everything at once, all the way from slime to humans. And that everything was linked, one to the next, all the way along the chain. So slime was almost bugs, and bugs were almost cells, all the way up to human beings being almost angels. Keep that in mind, because the next guy in my great chain had it in his. He was a German genius, diplomat, librarian and mathematical whiz called Leibniz. And in 1675, he decided to measure what was happening in the sky. This kind of happening. Leibniz was interested in the effect of the sun's gravity on planetary orbits, so he needed to calculate constantly changing velocity, like the rate this is falling now, at this infinitesimally small split second, not a zillionth of a second before, not a zillionth of a second after. The kind of math Leibniz developed to let him do that infinitesimally small measurement bumped him right up against the good old great chain of being, in which the graduation between one species and another, from slime all the way up, were, as you remember, infinitesimally small. So Leibniz said, I bet there are links between species so infinitesimally small, you can't see them with a human eye. And like all those hotshots you love to hate because they always win their bets, he only said that because he had seen them. 300 letters written by a Dutch shop assistant and microscope freak called Leeuwenhoek to this pompous lot of old twits in the English Royal Society. The letters are all about what Leeuwenhoek has seen through his new microscope, teeny-weeny animals. Shocking thing is, Leeuwenhoek says he's seen them everywhere, even. Huygens, being an intellectual, takes a theoretical approach to the problem. If light is what brings the images of anything to your eye, then how does light itself actually move? Huygens decides that light is made of little particles that hit other particles and pass their force on through them to others. In a straight line, like this. Except for some strange reason when light goes through a crystal called Icelandic spar, which splits the light ray in two. One refraction, the other, dunno. What Huygens doesn't know, because nobody knows, is that it's polarized light, which is as good a reason as any to head for Scotland. Things took a turn for the tartan when in 1828 an Edinburgh University geology type called Nicol, who was into rocks and crystals and such, fiddled around with a bit of Icelandic spar and came up with a thing called a nickel prism that would produce that strange polarized light on demand. Now, Nicol had already been making super thin slices of rock, so thin they were almost transparent, and looking at the rock structure detail with a microscope. And then he realized if you made super thin slices and shone the polarized light through them, some of the rock structures would affect the light according to what their molecular structure was. Like this, look. That's limestone, basalt, granite. Now, somebody somewhere was desperate to know about this magic ability to see through rocks, right? Except Nicol didn't tell anybody. So how do I know? Well, let me show you with a couple of polarized lenses. One on the camera, you put yours in, Jim, thank you, and one in my hand. Have you ever tried doing this with polarized lenses? See? That's because when you rotate the lenses, you rotate the polarized beams of light. And when the two beams are at right angles to each other, they cancel each other out. Then you go on rotating, and there comes the light again. In 1840, that trick boosted the whole economy because it got used to analyze sugar molecules, and sugar then was like petroleum today. Sugar profits encouraged investment in Scottish industry. Now, industry needed metal, and for that you needed better burning coal than Scotland had. Till some guy blasted hot air into coal furnaces. And bingo, you're looking at Scottish steel. Being able to use the local low-grade coal turned Scotland into an iron-making industrial country overnight. And all that ironstone and coal the Scottish miners started digging out of the ground kicked off a mining boom that would finally make nickel famous. Well, kind of. See, this fellow called Witham had met Nickel at Edinburgh University, and Nickel had told him all about those super-thin rock slices, remember? Now, the rock that turned Witham on, these are funny people, was coal, and especially the fossilized vegetables that the Scottish miners had started discovering in the coal seams. So Witham, what else, started slicing. You will have no doubt noticed that we are now in a place just a touch hotter than Scotland, right? It's Indonesia, actually, because this is where the story takes us in a minute. Meanwhile, that mining boom I mentioned and the fossil vegetables the Scottish miners started finding as they dug, well, Witham wrote one of those things you can't pick up, called Some Observations on Some Fossil Vegetables. And there was Nickel's work revealed. And the things he'd said about seeing little bubbles in rock crystals. Now, I told you there was somebody desperate to know all this, didn't I? Name of Sorby. Born, lived and died in Sheffield and never went anywhere without his mother. Crazy about bubbles in rocks. But bubbles like these, magnified 2,000 times. This photograph told Sorby whether the tiny bubbles had been made by hot gas, or hot liquid, or just heat. And you know what that does? Gives you a handle on all this. Sorby's microbubbles changed everybody's view about how rocks got made in the first place. Back in the incandescent days of the primeval era, when the planet was making itself in fire and lava. Back when the Earth began. All thanks to that weirdo Witham and his mania for fossil veggies.
This one? This? Oh, this one also. Good.
Things got back to vegetables again, real ones this time, when somebody introduced Sorby to something called a spectroscope. Works like so. You shine a light through a vegetable solution that absorbs wavelengths in the light according to what's in it. Then you shine that light through a prism and you get the familiar spectrum, but with black lines at the wavelengths of the light that have been absorbed by the stuff in the solution. So now you know what the stuff in the solution is. Good, thanks, great. By 1867, Sorby was doing that solution trick with boiled up autumn leaves to see if he could find out what caused them to change colour in autumn. Turned out to be a chemical you only see in autumn when the green chlorophyll disintegrates, called carotene, which is what gives plants their red, orange, yellow colours. Now, the thing about carotene is what you're looking at now, or any time. Because carotene's part of the way your eye works, and without it you can't see. Well, you can't see at certain times of day, or in certain circumstances which you can guess we are now approaching. Watch what happens when you go from light to dark, like this. First of all, you can't see anything in the dark bits, and then your eye kind of goes into automatic exposure mode, and gradually, here comes your vision back. A bit grainy, but you can see. Here's what's actually going on. On the retina at the back of your eye, you've got these purple things called rods. Very sensitive to dim light, so they let you see in the dark. When you go into a brighter environment, the rods bleach yellow. and you're now in bright light operating mode. It's carotene that does the trick by causing the yellow to change back to purple once you're back in the dark. Without carotene, that doesn't happen. So if you're carotene deficient, all you see in the dark is nothing. Which leads me to Indonesia's greatest gustatory delight, nasi goreng, which brings together chicken and rice, which is what I'm also about to do. You see, back in 1886, when the Dutch were running this country, they got all worked up about a very nasty disease called beriberi that was putting colonial administrators into hospital. So this young medical researcher called Eichmann notices some chickens, normally fed on hospital leftovers, staggering about with symptoms remarkably like beriberi. So he does nothing about it. Until one day, the hospital gets a new cook. Now, the new cook isn't going to give fancy rice specially prepared for Europeans, that is, polished, to chickens, leftovers or not. If the rough, unpolished stuff was good enough for the local Javanese, it was good enough for chickens. Shortly after this, Eichmann suddenly starts to notice chickens that aren't looking foul anymore. These birds are looking healthy. Takes a closer look at the problem and discovers it's the rice. Once the chickens had switched from polished rice to unpolished rice, they'd completely recovered from bird beriberi and become once again well enough to turn into nasi goreng. Turned out their disease was another one of those deficiency things, like carotene deficiency night blindness, remember? Without something in the hulls of the rice, which was missing when you polished the rice, the chicken got beriberi. But what was the missing something? In 1917, the whole thing hit the front page. World War I ships taking food to Britain were being hit so hard and so regularly by German U-boats that the country was in deep trouble. Britain was down to 4 weeks' food reserves. There was only one thing to do: tighten their belts and cut down on the amount of food you got. So Britain introduced rationing. But would rationing give people enough food to survive? Anyway, what was a healthy diet? So a guy called Gowland started taking a close look at the eating habits of rats and discovered that even if you gave rats more food than they could eat, without a particular kind of food in their diets, they wouldn't grow. There was something missing in their food, and maybe in human food too, that was having the same effect as the deficiency problems with chicken beriberi and that night blindness thing, remember? Something you needed as well as the basic carbohydrates and fats and minerals you got in food. Gowland called the something, whatever it was, accessory food factors. Which brings me back to that picnic and why I said at the beginning that modern food is better than theirs was. It didn't take long to find out what the mystery food factors were that you had to have in your diet. We call them vitamin A, B, B1, B12, C, D, and so on, because when they were discovered, we didn't know what chemicals they were, so they just got letters. So there you have it. Thanks to bikes and zippers and sewing machines and light waves and fossils and Dutch chicken, we got vitamins. And enrichment, enhancement, and all those other names we give it when the food's better than the real thing. Oh, you know what the food was that the rats weren't getting? Milk. Don't forget to drink yours.